Welcome back to the Coding Practical 3. Today we're on the exciting part. We're going to start making the game. So let's just drop right into it, alright? So first of all, what I want to explain to you guys is what the game essentially is or basically is. Don't mind my unprofessional way to present this, so I'm just gonna. Alright. What? No. Alright. So the game is basically. You can pause this and read this, but I'm going to read this out for you. Towers of Hanoi is an ancient mathematical puzzle that starts off with three stacks and many disks. The objective of the game is to move the stack of disks from the leftmost stack to the rightmost stack. I'm sorry. The game follows three rules. Only one disk can be moved at a time. Each move consists of taking the upper disk from one of the stacks and placing it on top of another stack or an empty rod. No disk may be placed on top of a smaller disk. In this project, we are going to use our knowledge of stacks to implement this game. Let's get started. This is what it looks like. So if I tell you this in layman terms, in this game basically there could be more, but there are at least uh, three stacks, and there could be many disks. All right, there are three stacks. All right, so you have to move the stack of disks from the all right, hold on, imagine this is how you start. So you have to move these from here, all of them, to the rightmost. All right, now there's a twist to this. You can't place a bigger disk on a smaller disk, right? And you have to try and complete this in a number of whoever completes, if you're playing with friends, whoever completes and then the least amount of moves is the winner. You have to try to complete it in the quickest way. All right, let's get started. All right, so the first part of creating the game is just creating the stacks. It says right there. So in this game, we're gonna be using our stack class, but we're also gonna be using our node one indirectly because stack one uses the node. So we're gonna be using our stack class. Usually, what you would have in your editor would be a tab right here opened as towers of Hanoi.py, and there would be another tab opened which would say hold up, which would say stacks.py, right? So there. So it could be two different things. And you could tab in, tab out, and you would basically just import the stacks class. If you don't know how to import, just say import 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 what was the spellings? Hold up. You would just say import stack from stacks.py, and if there were two separate tabs, but we're just gonna keep it in one tab. Keep it simple, keep it easy. Yep, alright. So back to business. We create an empty list that says stacks. This is basically where we're gonna store all three of our stacks. So we're gonna create a variable called left stack and instantiate the the stack class with the name left, right? Remember, put in the name. It's going to be named left. And then the middle stack, whatever you want to call it, instantate I called it instantiating, all right? Just going to instantiate your middle stack with the name middle, all right? Uh, And then the right stack, you're gonna implement the instantiate the right stack named right. Bro, I don't know how to pronounce these things, so if I'm pronouncing it wrong, please bear with me. So after that, we're just gonna uh, put that all into our list. Just gonna increment all three of these variables into our list. So that's just a list of our stacks. So once we're done creating the stacks, we're gonna get down to setting the game up. All right. Now underneath the setup the game comment, we have to create a variable num disks. All right, and set it to be equal to the int representation of our user input. All right, so whatever the user inputs, because if he inputs 5, it's going to be in a string data type unless we put int on here. So we need to get his input and put it into the integer data type. And what this text represents, you should know this, is when I'm gonna print this thing onto the screen, it's gonna say enter number greater than and it's gonna be, if I run this, right? How many disks do you want to play with? All right, this is, and then I just put on 2, but it won't let me play with 2 because you have to put in at least 3. So yeah, and this is gonna go keep on going. So I'm just gonna stop that. All right. So once we have our number of disks set, it's gonna. Joe, this is so distracting. I shouldn't have done that. Yeah. Right. So we're gonna make it so we can play with at least 3 stacks, because the game ain't fun unless they're like at least 3 stacks. So if it's less than 3, it's gonna prompt the same thing, and if it's still less than 3, so you're gonna keep on doing the same thing until we put in either 3 or something greater than 3, right? After that, what we have to do is we have to add our disks. We will represent the disks with the number disk 3 is larger than disk 1, etc. So after this while loop, we're going to create a for loop right here. And this for loop will iterate backwards through the range of num disks, right? Num disks, we have three disks. If I input it, if I input that I had 3 disks, it's gonna iterate backwards over those 3. So it's gonna go 3 to 1 or 1 to 3, right? And then on the leftmost stack, it's gonna push all those disks. So first it's gonna push the third, then the second, then the first. So that's where we're gonna iterate it backwards. Because remember, if I put in 3 here, how many disks do you want to play it with? I put in 3, and if I don't put in this, it's gonna go 1, 2, 3. So it's gonna put the smallest, and then the second big, like it's gonna put on the smallest, then the second smallest, and then the biggest, and that's not the game. You can't do it like that. The smaller ones need to be on top of the bigger ones, and if we start the game already with the bigger ones on top of the smaller ones, it's just gonna be wrong. So just gonna push them by iterating that num disk. We're gonna iterate that num disk range backwards and push that onto our left stack. All right. So the next thing we have to calculate for the user is the optimal moves. So the optimal moves is the fastest you can solve this. So we have to tell the user how many moves can he solve in like the fastest. So if I would have put in 3 disks, it would have been 2 raised to the power of 3, which would have been 8 minus 1. So the quickest you can solve this puzzle would be in 7 moves. All right. This part should be pretty simple. Right. We're done with that. Obviously, this is not a live interactable session where you can ask me anything. but I hope it's all clear for you. After that, once we're done with the number of disks placed on our stacks and everything sorted out, you have to get down to getting the user's input. So we're gonna create one huge method here. It's gonna be all in the get user input section. So we're just gonna put some choices in front of him. All right, choices would equal to stack.getName. All right, stack.get, like how am I supposed to explain this? Stack.getName for the zeroth index. So stack was a list, if you remember. Stack was a list which contained left, middle, and right stack. So it's gonna get the name. For example, if it's the left stack, it's gonna get it's gonna get its name, and then it's gonna put on the zeroth index. So what this is gonna basically do, I'm gonna explain it all over again. Stack.getName. So imagine it's the left stack, right? It's gonna get its name and put its zeroth index. So left stacks dot get name would return uh, it would return left, right? And left's zeroth index would be L. So what would be stored in choices? L, and then after that M, and then R. LMR would be stored in the choices list. All right, because it's gonna iterate over the stacks list, which is the left stack, middle stack, right stack, and then it's gonna get each of them's name, and then it's gonna store the zeroth index of the get whatever get name returns into choices as a list. So it's gonna be L comma, basically if I would have run this, the output would have been, it would look like this. Hold up. Choices equal, it would have been like LM comma, it would have looked somewhat like this. All right, pretty sure you guys have done for loops, because if you quite frankly, if you haven't done for loops, then I don't know what you're doing here, right? After that, we're gonna put in a while loop. Now you're gonna be asking yourself or me why we're putting on a while loop right here. All right, and I'm just gonna tell that to you just in another second. All right, because I'm basically processing for an easier way to explain this to you. All right. So, so why we're gonna be putting in the while loop just to check that the user made the valid choice. All right. So for I in range, length of the stacks is gonna be, hopefully you know this by now. The length of the stacks is gonna be, if I go back there, it's gonna be 3, right? For I in range 3, name is equal to stacks I. So once it's on the uh, zeroth index, it's going to be going like 0, 1, 2. It's going to return stacks on the zeroth index. And what is stacks on the zeroth index? It is the left stack. It's going to return its, get its name, and then our letter would be equal to choices. We've already defined our choices list. It's going to be choices is zeroth index, and the zeroth index would be L. So it would return to us, for example, basically on the zeroth index of stacks would be left stack, and on the zeroth index of choices would be L. So press L for left stack. Already went over for the dot format string method before, so I don't need to do that again. So after that, the basically the user input would equal to, we would ask for basically the user input would equal to the input. We're gonna put in these quotation marks just so it is stored as a string. All right, because like, remember this, we were asking for input and we're asking for input again. When we run this, it's going to print out asking the user to input something. It's going to say press L for left stack, so, and press M for middle stack, press R for right stack, and he's going to press something. So let's see what he presses. If now we have to check if he's made a valid choice, right? If the user has inputted, for example, left, all right, then the user input is in choices because L is in choices, remember? So for I in range length stacks, this would mean for I in range 3, right? For I in range 3, if user input equals to choices 0, choices 0 being L, return stacks 0, which would be the left stack. I hope this is clear. And imagine if you would have inputted something stupid like U, it won't even process all this code, right? It would just, it's a while loop, so it would go over again and it would ask him, it would basically print this code out again and it would ask him to input something again. But if he inputted something right, it would return him the stack he was asking for. So if it would have inputted L, it would have returned him the left stack. Now, let's get down to the part where we're playing the game. So this is basically the last part. So when we're playing the game, we started playing the game. Right now, the user movements are 0. We haven't made any moves. We haven't picked up any disks and moved them anywhere. So we're on 0 currently when we start the game. So while writeStack.getSize is not equal to the number of disks, print current stack for stack in stacks. Now, what this means is what this means is when the right stack is full, right, the game ends. So if the right stack, we're gonna check for if the right stack isn't full, because if it's full, the game is ended. But if it's not full, we're gonna print this. So we're gonna tell him what his stacks are, right? We're gonna show him that his current stacks are left, middle, right. All right. After we've showed him his stacks, that's why we're putting in while true. All right. Right. So which stack do you want to move from? From stack is equal to get input. If you remember our get input function, what is going to prompt him again would be to put in, this is going to be what he's going to be prompted to do again. So if he's going to put in he's going to put in his from stack, he's going to say from the left stack I want to move to the right stack. All right. If the from stack, now we're going to check for stack overflow or underflow. So if he's popping or removing something from the stack he's doing it from, if it is equal to 0, he can't do it because that's a stack underflow. All right. But if that doesn't happen, we also have to check something else, that we also have to check something else, which is, I have to rephrase this in a simpler way. So like all this code is doing is we will keep asking the user what move they want to make until they make a valid move. All right. After printing the stacks, but still in the while loop, we have to create a while loop, which is right here. We have to create a while loop for while true loop. All right. So while true. In this inner loop, we have to start off by doing the following. We have to ask him that which stack do you want to move from. We're gonna get his input and store that into a variable from stack. After that, we're gonna ask him what stack he wants to move to, and we're gonna stack that into, and we're gonna store that into a variable, the to stack. All right. Now we will make the first move. All right. So, but we have to check stuff before that. So before this, we're checking for the stack underflow, and if the size is equal to 0, or the stack dot peak is less than, now we have to check that if this part is okay, this part is not true, we're moving to this. So now we have to check if the disk he is moving, if the disk he is moving to has the top disk as a bigger disk, because if he's moving a bigger disk onto a smaller disk, that's not a valid move. So we have to check that if he's moving from the stack a smaller disk, then to the if he's moving a smaller disk from the from stack to a bigger disk to the to stack, that should be valid. That's what we're checking for. Otherwise, it's invalid. So disk would equal to from stack dot pop. We're gonna remove a disk from the from stack, and we're just gonna push it onto the to stack, and we're just gonna increment the num user movements by 1, and then we're gonna introduce a break into our code. But imagine if this was also false, right? This was uh if this was also false, then we would just simply tell him invalid move, try again. Because if this is true, right, if from stack there's no stack underflow, we were moving to this, and then the to stack dot get size, it's supposed to be equal to 0, which means it's empty, so we don't need to check if there's a bigger disk on it. But if it's not empty, we're gonna check if there's a bigger disk on it. If there's not a bigger disk on it, we're gonna move right here, and over here it's just gonna tell us that it's an invalid move, you have to try again. And once the user is done, which how we will know that, because the right stack would be equaling to the number of disks. So if we add 3 disks and the right stack would equal to 3, it's just going to end this and take us right over here to our last part. And we're just going to use the dot format again, and you completed the game in this amount of moves, and the optimal number of moves is this. Easy, right? Easy. So thank you guys for tuning in for this project with me. I've made a bunch of other projects as well, but we're just gonna go over this one in this course. So I hope you guys had fun and understood everything. If you guys didn't understand something, you could always contact me at this email, and I will try my best to get back to you guys. All right? Cheers.